Hello and welcome. In today's episode, we will dive deeper into 5 questions from radio navigation subject, and more specifically, the topic of PBN, so performance-based navigation. The 5 questions that we'll talk about are the latest questions that have been seen across all the EASA authorities. So these are the most relevant ones if you're preparing for your radio navigation exam. I'll try to give you some tips when it comes to the PBN topic, and we'll dive deeper into the questions and the answers themselves. So let's jump into question number 1 that we can see on screen right now without any further ado. So the appendix will show an ND where the required navigation performance, or the RNP, and the actual navigation performance and the ANP values are shown. Which of the following statements is a correct implementation of these display values? So let's take a look at this image. So on this ND, which is most likely taken from a Boeing aircraft, you can see at the bottom here in the green letters RNP, which is required navigation performance of 2, and an ANP, which is 0.05. So the RNP, or the required navigation performance, will relate to the type of route or the type of PBN operations that we are performing. In this case, 2 means that we can be offset of our route of a maximum 2 miles left or right. And if it's an RNP, this obviously means that our aircraft requires an onboard performance and monitoring system. Now, the ANP is a value calculated by our aircraft. It is ANP is an interchangeable term with EPE, which depends on the particular systems, and also signifies the total system error, or the TSE. In that case, 0.05 means that the system estimates that our total error in the worst case scenario can be 0.05, meaning from the point that we are currently shown at. So this doesn't mean that we are 0.05 offset. It means that in the worst case scenario, this system's error can have these values, but it doesn't specifically mean so. In most cases, if we are using a GPS signal for navigation and we are in the highly developed regions of the world, then these errors will be much lower and almost negligible. So going into the possible answers, of course, the EPE is shown, or the ANP, which is interchangeable. And then for the other answers, during the cruise phase, there shall be no warning if the EPE value is 0.05 higher than the RNP value, as RNP2 applies to the approach phase. This is incorrect. The approach phases will have 1 and even 0.3 RNP when it comes to it, in order to ensure better safety, because we need a better and more accurate navigation. The navigation system is performing to an accuracy of 2 nautical miles, and the airplane is within 0.05 nautical miles. No, the aircraft is performing to an ANP of 0.05, and the 0 below the aircraft symbol signifies our cross track at the moment we are flying on the pre-planned route. And lastly, the aircraft currently performing according to the RNP, but the warning will be given if the EP increases beyond 2. This is most likely correct. Depends on the aircraft. In my experience, you don't get a warning, but you'll get a caution. However, absolutely, you will be notified when the RNP is, if the EP is not sufficient. So now for question number 2. A student pilot wants to practice an RNP approach to LPV minima. In the planning phase, the pilot finds out she needs a FAS, or final approach segment, data block. The FAS data block is used too. So LPV approach, this is an approach that is flown with both lateral and vertical guidance, and both of these will use the GPS signal, and more specifically the S-bus. In order to get very accurate positioning, we need a satellite-based augmentation. So we are given these correction data from the satellites, and in that case we need a FAS data block, which is essentially a piece of data that describes the lateral and vertical track for this approach, and this is what makes these approaches so much more accurate than your standard LNAV, VNAV approaches. For contrast, if you're flying with a G-bus, for example, in that case the G-bus station will transmit the FAS data block using a VHF signal to your aircraft directly. And also, this is the reason why some commercial or airline aircraft do not fly LPV approaches, is because you need to buy this extra piece of information, this extra database that includes the FAS data block, and it simply is more expensive, and in most cases you will get lower minima for LPV approaches of 50 to 100 feet, depending on where specifically you're flying, so the risk and reward is not that big. In any case, the FAS data block will be used to describe the final approach path both laterally and vertically. This is a piece of information that will talk to the system's internal computers and essentially give you the correct path, which then is verified using the satellites, so you can fly very, very precisely using these LPV approaches. And we'll get to them in a bit more detail in just a couple minutes, actually. So for question number 3, for oceanic remote, en route, and terminal phases of flight, PBN is limited to. So this is a very specific question that may seem hard at first. However, with the process of elimination, it will be very easily understood, and you can very clearly and logically guess the correct answer, or I say make an educated choice. So going through all the possible answers here, you can see that they are differentiating between lateral and linear lateral performance. So here you need to remember that the angular performance, angular, lateral, and also vertical performance is something that is generally reserved to the approach phases of flight, as of course when it comes to lateral performances, it gets more sensitive as you are closer to the station. When you're flying in oceanic specifically routes, then of course having angular performance and angular navigation doesn't make much sense as you are covering enormous distances, meaning that this sensitivity factor of the angular tracks makes no sense, as they would be converging or diverging to a very, very large extent. And this is also why we use them in approaches, because as we are closer to the station, so when flying an ILS, MLS, GLS, and also LPV, which has an angular, which guides you with an angular deflection of the path. In that case, having a more sensitive system as you are coming to the runway will be nothing but beneficial, because you will have more and more accuracy the closer you are, and eventually this will allow you to fly to lower minima, and once you see the runway you can complete the approach much safer than as if you had just a linear one, as it is with, for example, the LNAV approach. So with that in mind, the oceanic remote en route terminal phases of flight will be limited to operations with linear lateral performance requirements and time constraints. So this is the reason, think about it like so, that angular gives you most sensitivity the closer you are, and less sensitivity the further you are, which is mainly beneficial for the approaches. This is how ILS works, and this is also how LPV works. And that's what makes them so accurate. So for question number 4, and here we can come back to the LPV in a bit more detail. So which of the following PBN procedures is classified as a non-precision approach procedure? So RNP approach to LPV, LNAV VNAV, GLS, or LNAV minima. So GLS, of course, is a precision approach. This is part of the ILS, MLS, GLS family. So these are the ground-based station that provide you the best accuracy for your landing, and of course they are considered precision approaches. Then we have the non-precision approaches, which in the most cases will be the 2D approaches, such as the NDB DME, NDB approaches, VOR DME approaches, etc., as well as the LNAV approaches, which only give you lateral guidance. The vertical guidance in most cases will need to be flown with you just calculating the descent down to the minimum descent altitude, and then once you see the runway, you'll be able to go and land. However, now in the ICAO and EASA have decided to add an approach called APV, so approach with a vertical guidance. And for example, the approaches with vertical guidance, or the APVs, are a no man's land at the moment. So they are neither precision or non-precision approaches. And one of them will be the LNAV VNAV approach, for example, because it guides you using the VNAV baro, for example, baro VNAV. It does guide you vertically. However, it's not precisely a precision approach. The same will be true for the LTV minima, which is not necessarily a precision approach. However, it can be flown down to Cap 1 precision approach minima. And this is why in a lot of exams, this will be classified as a precision approach, at least for the question's sake. However, out of these questions, the most correct answer will be the LNAV minima, as this approach is a 2D approach. All of the others are 3D approaches. So remember that the LNAV approach only guides laterally, making it definitely a non-precision approach. And lastly, for question number 5, your aircraft is approved to conduct RNP approach. Can you fly RNP 2? So this is one of the big questions that comes up a lot and will come a lot during your exams, and then further on, most likely, and possibly airline interviews, and then type rating, and so on and so on. So can you fly essentially a higher RNP than you are approved for? So logically, it makes sense. You can maintain your cross track 2 nautical miles left or right. So why wouldn't you be able to fly an RNP 4 where you have to maintain a cross track of plus minus 4? However, the answer is no, you cannot, and drill this into your head, as I'm sure this will come up many, many times in the exams and both ATPL and your practical ones, and then further on your career. And the reason is that different RNP specifications will have different requirements. So this is not necessarily only regarding the navigation capabilities of your aircraft. For example, some RNPs or RNAV specifications that will be created specifically for oceanic flights will have much different specifications than the one made for normal en route or approach phases of flight, and these will have to do with the regulations, with the safety and redundancy. This is not something we need to know. However, you need to remember that you cannot just fly a higher RNP because you are approved for the lower one. You always need the specific approval. And this will be everything that we have here today. Thank you so much for tuning in. I hope this was interesting. If you have any questions, feel free to ask. I'll do my best to answer. And in any case, I hope to see you in the next video, and I wish you all the best with your exams. Bye-bye.